In this video I'm going to be spray painting the colour of my Amiga a different colour, but I'm not going to actually video that. By the end of the video the colour of the Amiga is probably going to be a different colour. But in this video is about the keyboard, so some of the keys work just fine, but there's an area around here which don't actually work, and the enter key, which is most important. Also some of the keys on the numeric pad don't work either. And I've had to go at repairing this before, and when I take the keyboard apart I'll show you what I've done before and why I'm not going to continue in that vein of approach. But what I'll do is I'll talk about how I'm going to actually go about repairing the keyboard so that it's a permanent and good repair. So when you undo the 3 screws on the bottom along the front, along the back, another 3 screws along the back, the lift off the top. Now I've got the audio amplifier I've just added to unplug here, and then the keyboard just unplugs by putting off that connector there and lifts off, and then to get inside the keyboard you need to unscrew all of these small screws along the back. There's lots of them. So this is the keyboard when it's apart. So this is the top half and all the mechanisms in there, and it's got, each key has some rubber that's conductive in there which pushes down across traces on here, and it makes a connection which goes to the keyboard controller, which sends information back to the computer. So this top part of the keyboard, that's all stable and together, so you don't have to worry about that. And this bottom part, what's happened is, I guess over time, this wasn't my computer originally, it must have got a lot of use, and some of these traces are broken, so I've used some silver paint to actually remake the connections of the traces. But in order to do that you have to actually get a knife and rub off some of this plastic, because the traces are embedded in between 2 sheets of plastic, and so it's really hard to do. And I managed to recover a couple of keys and get them working again, but there's still a bunch that need to be done, and this silver paint, well, it's decades old, and so it's probably not very good. But also painting on this very shiny surface is really tricky with the silver paint. It like smears everywhere, so that's not a good solution anyway. So what I'm going to do is I'm going to get some copper clad board like I've got here. So this is, I usually get it in like A4 sheets basically, but this isn't long enough to do a whole keyboard, so I'll probably separate it into numeric keypad and alphanumeric keypad. So the alphanumeric's on that side, and then I'll use a bit of my cut off from other projects to do the numeric keypad. And I'm going to try and replicate the tracks on here onto the copper clad board, and then replace this and probably this metal sheet with the copper clad board, and somehow connect it to this connector, probably remove the connector and use the holes that the connector is in to solder it onto the actual copper clad board. But that's the plan, and hopefully it should work. So this is the membrane from inside the Amiga, and it's a piece of plastic with traces on the top and also traces on the back, so that it jumps across some traces on here. But it's not like a membrane like some keyboard membranes where you have 2 sheets of plastic and you make contact between the top and the bottom. This one's just a single sheet of plastic, but it's got these carbon covered pads where the key arcs across the 2 pads to make a key press. It's very lightweight, so I thought, well, in order to duplicate this, rather than trying to work out where all the traces go and using an ohmmeter or whatever to go from pad to pad and decide which ones are connected to each other, I thought if I get this inside the computer as a photograph or something, what I can do is I can get it into KiCad, and then all I need to do is put it on the layer in KiCad and then trace over the top of the traces and on the copper layer, and just lay out the tracks myself. I thought if I could get it in as a 1:1 scale scan, then it would be really simple to make this into a PCB. So I've got this document scanner that I've had for a long time. I usually just scan A4 sheets of documents in here. Now this keyboard membrane, it's narrower than an A4 sheet, so it'll go through here, but it's much longer, and lucky enough the document scanner does most of it. I think I had to do it as 2 scans still though, and what I did was I got a piece of paper like this. I sellotaped it to the top, and then with this sellotaped on top I scanned it with the scanner, and that then saves it as an image file on SD card out there. So that got the image into a form where I could get into my computer, but then I needed to get into KiCad. So these are the image files that I got into the computer as a first stage of getting them into KiCad. So I'll go through the images which I've got here. Now this first one was an image that I took a photograph of the actual keyboard matrix. Now I stuck it to the side of an arcade cabinet with some blue tack. But this turned out to be not successful because when taking a photograph of something, it's really difficult to get the top and the bottom of the item in perspective. So I found that it was either trailing to a narrow degree at the top or trailing to a narrow degree at the bottom because I couldn't get the camera quite parallel enough. So I gave up on taking photographs to get it into KiCad. And also there's a lot of glare from light. It's very difficult on the shiny surface to stop getting glare, and that got in the way. So then I went to the scanner. I've got 3 stages which I went through of doing it on the scanner. So like I say, I had to do it in 2 halves because the scanner would stop at just over A4 page size. But it meant that I could get it in like here. So this is one half of the keyboard. And then I also did one for the right hand side of the keyboard in exactly the same way, but putting it through the scanner in the opposite direction. And that gave me a nice, there's no parallax issues with that at all, because it's going for a flat scanner with a very parallel scanning device. So then what I did is I took it into GIMP or any photo editing software, and I got this negative version of it first because I wasn't sure whether the negative would be better and easier to get into KiCad or a positive version. So I produced both a negative version and a positive version of both sides, left and right hand side. So this is the positive version. I ended up going with the positive version in the end because it was easier to get into KiCad, and I'll go through the stages which I used to get into KiCad. But I've still got 2 halves of an image here. And to get to this clarity in the photo editing software, make it into a black and white image, then adjust the contrast and the brightness to get as clear an image as possible with as little noise as possible. You can use some of the filters as well in order to help get just the black and white image. This was actually quite a decent rendering, which I managed to get out of GIMP. So then after that, I ended up with two images. Now I took it from an image from the perspective of the bottom of the PCB because I wasn't sure whether I wanted the top or the bottom. So that's the bottom one, and also a perspective of the top, and that was just in the image in the GIMP to actually flip it horizontally, and so I could get both a bottom or top image depending on how I decided I wanted to actually trace over it in KiCad. And I've merged the left and the right images together. And I've managed to get as parallel as possible, and actually this turned out to be just good enough for actually using, but I still had to get into a format which could be read by KiCad. So I think the only format, at least with the version of KiCad that I've got, that you can import is a .dxf file. So the way I found to actually convert this JPEG file into a DXF file is to open it with that application called Inkscape, and then just select the default options, click on OK, and when it's imported into Inkscape, I just maximize the window. Okay, then select the image by clicking on it and right click, and then trace bitmap, and then just click on OK, and then it's finished doing that, so just close that window and then go File and then Save As, and in the file types there's a DXF file format, and I'm just changing the extension to DXF just to make sure it saves it as that, and I'm going to save it into there. Yeah, so click on Save and just click the default options again, and then when that's finished doing that, I'll just close this Inkscape because I won't need Inkscape anymore. Okay. Don't need to save it as SVG, and that's fine. So now I've got this DXF file here, and if I go to KiCad, I've opened up just a temporary project, and in here under the file menu, you can. So I've opened up a blank PCB. So go on the file import and then import graphics, and then select the file that you want. It's already selected the file, and then I had to change import scale to 0.6, so I think it was 1. I think it's around 0.6. I might have adjusted it a bit, but you have to experiment by actually doing a scaled printout and just line it up to the membrane and make sure that it's the right scale. But I think it was around 0.6 that I imported it as. And click on OK. And what that does is it generates a layer, which is the image file, which it's about 3.4 megabytes, so it takes a little while to load in, especially on my virtual machine. So if I hit the home key, it'll zoom out to, oh no, I have to place it first. Okay, now I can hit the home key and it should zoom out to show the whole thing. So now it's imported like this. When it's impossible to work on it fully zoomed out because it's so big. So you have to hit F1 to zoom in. And what I actually did was I zoomed into this kind of level, probably zoomed in a bit more than this, selected a track, and my tracks I wanted at least 0.5 millimeter, so I did the 0.5 millimeter tracks. It's currently on the default of 1/4 millimeter, and all I did was where these tracks are, I traced the tracks along here, and I placed pads of appropriate types around the pads, and on the fingers up here I place stuff. I'll open up the actual file which I produced, but that's how you get the thing into trace, and then the next stage is to actually go over and lay it out, and I'll open up the actual project file which I've produced. So here's the actual project files for KiCad which I produced, and if I open up the project, and so there's no schematic because I'm doing a trace over the actual image files which I produced. So if I open up the PCB files, because I'm capturing the screen, unfortunately it takes a little while. There it is. And so this is actually the files which I ultimately used. And there's not much to say apart from I basically traced over the image file like you saw previously, and also the actual holes to punch out. So there's these yellow holes in the actual PCB which go around the screws which go through the PCB. So you need those holes in the right place. And the way I got those into the right place was when I print out a PDF of the circuit, so for producing at home using ferric chloride, whatever, on my actual PC screen, it actually shows exactly 1:1 ratio. So I could overlay the matrix, the Amiga keyboard matrix on top of the actual screen. I could see how well things were lined up, and that was immensely helpful to be able to do that, because I can go through trial and error and get it as correct as I can. The only other thing to say about this actual layout is the actual front mask, the solder mask. So it's important on the edge connector at the top there that I've got the solder mask there. Otherwise, the actual connectors will actually be covered up with solder mask. So you need to mask that off so that it doesn't get covered in solder mask. And also the pads, because I'd made custom pads to make them as big as possible, so that if I was slightly out, that the actual pads themselves would be big enough to cover any errors that I produced into the actual PCB. So I've actually made the pads bigger than they are on the original actual keyboard matrix, and that's a good idea to do that where possible. Apart from that, it took ages to lay this out. I thought, oh, it's just going to be a trace and it'll be really quick, but actually when you come to trace over these things, you find out the number of tracks is a lot more than they look. And I was probably a bit more picky than I should be, and also if I did it again, because I know what I was doing, it'd be quicker, but it did take a long time to lay this out. And then in the end, because I thought, well, there's a few things I've got, if I make it at home, then first of all my PCB is going to be 1.6 millimeters, which is really thick. I won't be able to use the edge connector. Also, I'd have to drill out the holes myself, which would be a problem. That I can only make one-sided PCBs for this kind of thing, so I'd have to put wires in, and so there's so many things that I'd have an issue with. So I decided to send it off to a PCB manufacturer in China, the design files, and get them made over there. So I did a test fit on my Amiga and tried it out. Unfortunately, there was an issue. So these keys which I've circled here, when I press those, I get the key press and then I get a stream of other characters. Whereas all these other keys, they work fine. No problem at all with these other keys. And I've put on the silk screen all of what the keys are supposed to be, so that if it came to testing, I could actually look up what the value was and actually put a wire between pads and do some tests and stuff. And what I thought this was at first was that I'd maybe connected a track with another track, which I shouldn't, which would cause an issue. And I was hoping that it wouldn't be that, because I don't really want to wire patches of wires onto this, as it's supposed to be thin for a keyboard matrix. And lucky enough it wasn't. I didn't cross the tracks because it would have been easy to do, because I didn't have a circuit in a schematic in actual KiCad. When I was laying down tracks, KiCad didn't know what track was bad to connect with another track, so I could have easily done it without KiCad warning me. That's one of the things about tracing over without a schematic. But I'm so glad that it wasn't that, and I don't need to do anything like that. Then I thought, actually, maybe the connector at the top here, that's the only other thing I could think of. Maybe I'd not aligned those properly, and I did find out that actually I put a slightly thicker edge on one side than I did on the other, so maybe it was like left or right badly aligned. So I started messing around with that, and again it turned out not to be that either, so that was a relief. So actually this keyboard matrix turns out to be perfectly fine, and I got a 0.4 millimeter keyboard matrix actually, and which means this connector can actually fit into the connector which is on the keyboard adapter, which is in the Amiga itself, so that's perfect as well. The 0.4 millimeters is as thin as the PCB manufacturer which I went to could go, or at least went to for quick R&D type production, small runs sort of thing. Maybe they can probably do other things as well, but this was ideal for me because it was a bit more expensive than the regular thickness boards, but it was still good because it's going to be a permanent solution, because it's not like the original matrix where it can wear out again. This should last forever. I want to put this in my computer and actually try it out for a month, try typing on it for a month, and see if it does withstand a month's use of heavy use. But what it actually turned out to be with this is on the back, because the wires on the back, I expected them to be well covered with solder mask, but actually the wires aren't completely covered, and because it's a metal background that goes onto in the Amiga, so it lays on a metal sheet, and then the keyboard lays on top of it, and actually some of the wires must have been shorting out on the back. So what I did was put some tissue paper between the metal and this keyboard PCB, and it solved the problem. So that's all it was. So I'm so glad you take the time to go over and over and over again when you're actually doing the layout to try and resolve any issues before you send off for the PCs is well worth the time spent. So I'm going to put this in the computer now and demonstrate it. So here's my keyboard for the Amiga. It's got the PCB here, the mechanics there, and then the metal plate here. I'll just take the tissue paper off the metal plate for now. I'll put that in at the very end. So I've got the keyboard controller over here, which has to go on from the back. And the PCB, it's going to be hard to do this without it being on the desk, but the 0.4 millimeter PCB fits into the keyboard connector just fine, and then push that back to actually lock it in as you would normally. So I'll put this back together and screw the screws in the back, and then I'll try it out and make sure the keys work. So this is my Amiga back together again, and while I was waiting for the PCBs to arrive, I painted it because the casing was yellow. I didn't feel like doing the retro bright in there. I've never done that before, and it's not. I thought it'd be quicker and easier to paint the Amiga. I've got a couple of other Amigas which are like pristine condition, so I didn't mind painting this yellow one. And I've painted the keys as well white, and then put labels on the keys as the legends. And now I'll just run through all the keys and do a quick key test. Okay, so I've pointed my monitor at my display, and I'll just go through all the keys. The function keys come up with tilde characters, but goes through all the 10 function keys, then tab, and then the QWERTY and brackets, enter key, and then caps lock key on, and then press an A, caps lock key off, and this next line, enter, and then hold the left shift down, press Z, then without the shift down, and the right shift down, press M, space bar, the Alt Z, and right Alt Z, and the cursor keys, up, down, left and right, the delete key, help key, then the numlock key, and going through the numeric keypad. And so all the keys work fine.